Here's a story problem from a practice SAT that says that a company provides whale watching tours on groups of 21 people at a time. The company's revenue is $80 per adult and $60 per child. If the company's revenue for one group consisting of adults and children was $1,440, how many people in the group were children? So this is a pretty standard system of equations set up if you're dealing with a story problem that results in one. There are two equations that we can come up with. The first of which is going to be for the total number of people on the tour. The number of adults plus the number of children has to total to 21. And then the second one is going to come from the amount of money that the company takes in. $80 times the number of adults plus $60 times the number of children has to total $1,440. Now, the way that you solve this system of equations doesn't have to be exactly what I'm doing here. You could use substitution, you could use a graph, you could, if you wanted to, use guess and check. You do know that one of these choices has to be correct, so you can try to plug in these values for C, right? How many children went on the tour, and see which of them works out for both equations. I went with the direct route of solving the system with elimination. I realized that I was only concerned with the number of children on the trip, so I thought, well, if I can eliminate A from my equations, that would be a good thing because I'll get directly to my answer for the number of children. So what I realized is I could multiply this top equation by 80, so that A gets multiplied by 80, the C gets multiplied by 80, the 21 gets multiplied by 80, and that leaves you with the equation that you see here that's in that set of parentheses. To eliminate A, now that I have 80A in my second equation and 80A in the equation we just produced, I would subtract to get to 0A, but I would also have to do 60C minus 80C, leaving me with negative 20C. I would have to do 1440 minus 1680, leaving me with negative 240 on the right side of that equation. Isolating C, one step left, divide both sides by negative 20. The negative divided by the negative produces a positive answer, and we are looking at 12 children as the number of children on the trip.